Welcome. In this session, we will explore two critical benefits of cloud computing: high availability and scalability. We will define these concepts, understand the mechanisms that drive them, such as availability zones and auto-scaling, and see how they ensure your applications remain operational and efficient under varying conditions. Let's begin by defining our core terms. High availability focuses on ensuring maximum availability of your IT resources, regardless of disruptions or events that might occur. It is about keeping your systems operational. Scalability, on the other hand, refers to the ability to adjust resources to meet demand. If your traffic spikes, scalability ensures your system can handle the load. If demand drops, scalability ensures you aren't overpaying for services you aren't using. Together, these pillars support a reliable and cost-effective cloud environment. This diagram illustrates the relationship between these concepts. We start with the core cloud benefits. On one side, we have high availability, which flows into a focus on uptime and reliability, keeping the lights on. On the other side, we have scalability, which flows into handling demand, changes growing or shrinking as needed. Both are essential for a robust cloud architecture. When architecting for the cloud, you must account for service availability guarantees, known as service level agreements, or SLAs. Azure is a highly available environment with specific uptime guarantees depending on the service you use. This is tied closely to reliability, which is the ability of a system to recover from failures and continue to function. By leveraging these guarantees, you ensure your application meets business continuity requirements and remains accessible to users even when individual components fail. This state diagram visualizes the lifecycle of high availability. The system begins in an operational state, governed by an SLA. When a disruption or failure event occurs, the system doesn't just stop. It moves to a recovery phase, often through automatic failover mechanisms. Finally, it returns to the operational state. High availability is about minimizing the time spent in that middle disruption and recovery loop. How do we achieve this availability? First, we use availability zones, which are physically separate data centers within a single Azure region, equipped with independent power, cooling, and networking. If one zone goes down, the others continue working. For broader protection, Azure uses region pairs, where a region is paired with another in the same geography to reduce the likelihood of interruptions caused by natural disasters. On a smaller scale, availability sets group VMs into different fault and update domains to ensure they aren't all rebooted or affected by a hardware failure simultaneously. This diagram maps out the infrastructure of availability. On the left, we see region, containing 3 distinct availability zones. These provide local redundancy. This entire region is then connected via geo-replication to region B, the paired region. This layered approach ensures that whether it's a single data center failure or a regional disaster, your data remains protected. Now we turn to scalability, starting with vertical scaling, often called scaling up. This involves increasing the capabilities of your resources. For example, if you are developing an app and need more processing power, you would add more CPUs or RAM to your existing virtual machine. Conversely, you can scale down by lowering specifications if you over-provisioned. While useful, vertical scaling has limits. You cannot exceed the maximum hardware size available, and the process might require a reboot, temporarily affecting availability. This diagram visualizes vertical scaling. We start with a standard virtual machine class with 2 cores and 4 GB of RAM. The arrow indicates the scale-up action, resulting in a scaled virtual machine with significantly higher capacity, 8 cores, and 32 GB of RAM. The object itself changes size, representing the increase in power within the same unit. The second type is horizontal scaling, or scaling out. Instead of making a single server more powerful, we add more resource instances, such as additional virtual machines or containers. If demand drops, we scale in by removing instances. This is the essence of cloud elasticity. It prevents you from overpaying because you only pay for the resources you are using at that moment. This method is flexible and ideal for cloud environments where you need to run a large number of VMs to handle variable loads. Here we see horizontal scaling in action. We have a load balancer distributing traffic to VM instance 1 and 2. When a high traffic event occurs, the system triggers a scale-out action. This creates VM instance 3, highlighted in green. The load balancer then automatically routes traffic to this new instance, maintaining performance without changing the existing servers. To manage scalability efficiently, we use autoscale. You can set up rules to automatically add resources based on specific conditions. Metric-based rules trigger when a value, like average CPU usage, exceeds a threshold, such as 70%. Time-based rules trigger on a schedule, which is useful if you know traffic peaks at specific times, like Monday mornings. Additionally, predictive autoscale uses machine learning to forecast overall CPU load based on historical patterns, scaling out in advance to meet predicted demand. This sequence diagram shows the automation flow. The app reports high CPU usage to the monitor. The monitor sends a metrics alert to the autoscale engine. The engine evaluates this against its rules and sends a trigger scale-out command to the resource group. Finally, the resource group adds a new VM instance to the app, resolving the load issue. In summary, the combination of high availability and scalability leads to reliability and predictability. Reliability is achieved through decentralized design and global scale, ensuring systems function even if a region fails. Predictability applies to both performance and cost. Performance predictability means using autoscaling and load balancing to deliver a consistent experience to users. Cost predictability is achieved by tracking resource use in real time, allowing you to forecast spend and adjust resources as needed. Our final mind map consolidates these benefits. Cloud benefits branches into reliability and predictability. Reliability enables recovery and global scale. Predictability branches into performance, driven by autoscaling, and cost, driven by real-time tracking. This holistic view confirms why the cloud is the preferred environment for modern workloads.